This is section 4.8, triangles and coordinate proofs. And what we're doing is just graphing the situation it indicates. This is a right triangle. So we need a right triangle called FGH with the sides of A units and B units long. What that means is that they're just different sides. So we can call this the A. And the good thing about this section is that you can make up your units, and that could be B. Reconnect it, and this is the point F, the point G, and that means that this point right here would have to be H, and we have to call it a right angle since it's a right triangle. On the next one, we have an isosceles triangle KLP with the base of KP 6B units long. So what that means is here's 1B, 2B, 3, 4, 5, 6. That means that right here would be that point K, and over here would be the point P, making this 6B units long. It wants an isosceles triangle, so halfway there, 1, 2, 3, we got to make this dotted line like this. So that vertex L has to be on this point. The other cool thing, since we're making up the units, you can make it really close to the KP or really far away. I'm going to make it far away this time. If I would have spaced out the lines correctly, we would have been able to tell that these two lines would have been equal. Okay, on 3. We have an isosceles triangle AND with the base of AD 5 units long. So we have 1A, 2, 3, 4, 5. So this would be 5A. That means that this has to be the point A, and this one has the point D. Remember, we have to go halfway, that's 2.5, to then draw the line up to make our point. This one I'm going to put really close to the AD. Making this one equal to this one, and since I spaced it out better, you can tell that they are really close in size. This one has to be in to make the triangle A and D. So I'm sorry about that, but on this one, I forgot to label this point L. All right. Name the missing coordinate of each triangle. So here they're telling us that this is 2A units on the X. This makes it 1A, and that's 2A. And then it wants an isosceles by this marking. That means that this one has to be 1A, and this one has to be 2A. Making the Y value 2A, that makes the order pair for the point A 0, 2A. So since this distance has to be 2A long, so does this one, making it your Y value. All right, on number 5, we have that this is 2B. Remember, we have to go halfway, so this is 1B right here. It goes straight up to make this point Z. That means that your X value is 1B. And your Y value, remember how we could have made it really close to the line or really far away from the x-axis? That means that we actually don't know the measurements, and we could call it A. Just something different than B. It doesn't have to be the same height as B. Now number 6. It doesn't give us information, for example, how long this is compared to this. and so they're not the same. We don't know anything about the values, but we do know that it's on the y-axis. That means x has to be 0. And since we don't know anything about how high it has to go, we call it a, just a different variable. On 7, this has to be halfway from the corners over here. That means this is 2a, that's 1a, and this is 2a, making this corner all the way over here 4a, because this would have to be 3, and this is 4. That's your x value on the cue, 4a. And since it's on the x-axis, the y value has to be 0. All right, next. Number 8, it gives us that this is all the way at 7b. We have to go halfway to get this point right here. That would be 3.5. Making your r the 3.5b units. And what I'm supposed to teach you is the Pythagorean theorem to say how tall it is, but we won't do that. We just don't know how high it is for right now. We're going to call it a. Okay, for 9, we have negative a to a. That means that this point is still on the 0. It's on the y-axis, so your x value is 0. Since we don't know how tall it is, we can call it b. Just a different variable. You don't want to call it a because that's already on the x-axis. For number 10, we got the proof. And I'm going to write down the proof and then I'll explain it. But for right now, let's go ahead and draw a picture. I want you to draw the y-axis and then the x-axis. I'm going to draw this triangle A, B. Oh no, B has to go right here because it says that's the right angle. Then that means this one has to be C. It says that the isosceles right triangle ABC has a right angle at ABC. That means B is the one that's the right 90 degrees. And that's why I had to change the order of the letters so the B can be at the 90 degrees. Since it says it's isosceles, then I'm going to make these two sides equal. And then it says that M is the midpoint of AC. So M right here would be in the middle. I'm going to draw a line because what we want to prove is that BM is perpendicular to AC. Let's start our proof. These are your statements. And this is the reasons. Number 1. I'm going to write it this way. Triangle ABC is a right isosceles. And that information was given. The other part that was given is that M is a midpoint. To the segment AC. Two. I can say that the segment AB is congruent to the segment BC because they're isosceles. So we say definition of isosceles. I can also say that the segment AM is congruent to the segment MC. So that segment AM is congruent to MC by definition of midpoint. I'm going to continue my proof over here. Going to draw the line like this. I'm going to call this number 4. I can also say that angle BAM is congruent to the angle BCM. And that's because of the base angles. So we say isosceles base angles. I'm going to draw that information in my diagram. Okay, so it was given. I just said that these base angles are equal to each other because they're base angles of an isosceles. Because these two sides are equal, then these two angles are equal. I also said that this segment is equal to this segment because it's a midpoint. Now I have enough to prove that these two triangles right here are congruent by side, angle, side. So 5, I'm going to say that the triangle ABM is congruent to the triangle CBM by side, angle, side. Now that we have the two triangles are congruent and all the parts are congruent, including the angles, angle BMA is congruent to the angle BMC, and that's by corresponding parts of congruent triangles are congruent. Now that they're both equal, we can say that they're both right angles. So angle BMA and angle BMC are right angles because they are a linear pair. Now that we know that they're both right angles, we have just proven that these two segments are perpendicular.